Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing basic probability and expectation. So we will begin with probability. A box contains 3 blue pens, 4 red pens, and 8 green pens only. A pen is chosen at random from the box. Find the probability that this pen is green. So the probability that this pen would be green is basically the number of green pens divided by the total number of pens that we have, which is 3 plus 4 plus 8. And this gives us 8 over 15 as a final answer. The diagram shows 5 cards. In I, we are required to find the probability that the number of dots is even. So let's write them out. Let's write down the numbers. So this is 3, 2, 4, 2, and 2. In terms of even and odd, this is odd, even, 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 and even. So the probability of an even number is 4 over the total, which is 5. And then we want the probability that the number is a prime number. So 3 is a prime number, 2 is a prime number, 4 is not, 2 is a prime number, and 2 is a prime number. So again, the probability here would be 4 over 5. In both cases, the answer is 4 over 5. The probability that Stephanie wins her next tennis match is 0.85. Find the probability that Stephanie does not win her next tennis match. So when we have two events that are opposite of each other and there cannot exist a third alternative. So she can either win or not win. Of course, you might start thinking to yourself, she could lose and it could be a draw. So there are 3 scenarios, but both losing and ending in a draw are not winning. So she can either win or not win. So the probability of winning plus the probability of not winning, which we will call W dash, must be 1. So therefore, the probability of not winning, if we denote it as P, for example, must equal 1 minus 0.85, which is 0.15. So if she wins with the probability of 0.85, then she does not win with a probability of 0.15. Not winning here could mean losing or ending in a draw. This doesn't really matter. But the answer is 0.15. The probability that Pedro scores a goal in any match is 2 over 5. Calculate the probability that Pedro scores a goal in each of the next 2 matches. So he needs to score and score again. So he needs to score in the first match and then score in the second match again. So when we say and, we multiply the probabilities. So 2 over 5 times 2 over 5. And this gives us 4 over 25 as a final answer. The diagram shows a fair spinner. Anna spins it twice and adds the scores. Complete the table for the total scores. So here, to calculate the total scores, you simply add the row and the column. So 1 plus 1 gives us 2. 1 plus 3 gives us 4, and so on and so forth. So here we have 4 plus 1. Let's change the color. Let's clear the drawings. So here we have 4 and 1. So 4 plus 1 gives us 5. 6 and 1 gives us 7, and so on and so forth. So 4 plus 3 gives us 7, 7, 8, and 10. We are adding the column by the row. So 6 plus 1 is 7, 6 plus 3 is 9, and then 9, and then 10, and then 12. These are the numbers that we should put in the table. In B, we are required to find the most likely score. So we want the number that was most often repeated. So 2 was not repeated a lot. 7 was repeated 5 times, or 6 times actually. So let's just circle them out. So these are the 7s here. We have 6 7s. So we got 7 6 times. you can create a frequency list like this. And then we got 2 only once. And then whenever you finish something, you can just cross it out slightly so that you don't have to look at it again. For the number 4, we have 1, 2, 3, 4, and that's it. So for the number 4, we saw that 4 times, and again, we can cross it out. For the number 5, we saw that twice. So the 5 appeared twice. And then for the number 6, we have 1, 2, 3, 4. So the number 6 appeared 4 times. Of course, here, this is the value and this is the frequency, which we saw it. And then for number 7, for number 8, we saw that only once. For number 9, we saw that 4 times, 1, 2, 3, 4. And for number 10, we saw that twice. And for number 12, we saw that only once. Of course, we didn't have to go through with all of this. Midway through, you must have realized that the most frequently occurring number is the number 7. So the most likely score here is 7. Now we want the probability that Anna scores a total that is less than 6. So the total that is less than 6 could be 2 or 4 or 5. Either 2 or 4 or 5. And these occurred with 1 and 4 and 2 times. So 1 plus 4 plus 2, that gives us 7 times. So these occurred a total of 7 times. So we have 7 divided by the total number of possibilities. And here we have 5 numbers and 2 spins. So we have 25 possibilities, 5 times 5. So the answer is 7 over 25. Now we want a total of 3. And of course, 3 did not appear at all in the X column. So we don't have a score of 3 to begin with as a total. So therefore, the probability is 0. And 7 and 7 over 25 and 0 are the correct answers. The probability that Andre cycles to school is R. Write down in terms of R the probability that Andre does not cycle to school. So we said that when we have opposite events, their total probability is 1. So therefore, the probability here would be 1 minus R. The probability that Benoit does not cycle to school is 1.3 minus R. The probability that both Andre and Benoit do not cycle to school is 0.4. Complete the equation in terms of R. So the probability that both of them do not cycle to school is the probability of the first times the probability of the second. We just have to put here 1 minus R and 1.3 minus R. And now we are required to show that this equation simplifies into this equation here. All you have to do here is expand. You have to multiply first by first. You get 1.3. Then first by second, we get minus R. Here we get minus 1.3 R. And then here we get plus R squared. And all of this is equal to 0.4. And then we collect the like terms. So we have R squared, and then minus R minus 1.3 R. So this is minus 2.3 R. And then we take the 0.4 to the other side. So we have plus 1.3 minus 0.4 equals 0. So R squared minus 2.3 R plus 0.9 equals 0. And then we can multiply everything by 10. So 0 times 10 is 0, so this does not change. On the left, we have 10R squared minus 23R plus 9 equals 0. And now we have arrived at double I, excuse me. In triple I, we are required to solve this by factorization. So we're looking at two numbers times each other. That would give us 90. So A times B equals 90. And then A plus B equals negative 23. And of course, both signs here are going to be negative. We're going to have two negative numbers. We need to look at the numbers that multiply to give 90. So we have 1 times 90, 2 times 45, 3 times 30, 4 would not work, 5 times 18. Of course, 5 times 18 is the correct answer here because 5 plus 18 gives us 23 and 5 times 18 gives us 90. So, and since they want negative 23, so it's negative 5 and negative 18. Now we write 10r minus 5 and 10r minus 18. And finally, we simplify. So we divide by 5, we get 2r minus 1. Here we divided by 5 on both sides. Here we divide by 2 on both sides. So we get 5r minus 9. So now that we have our two brackets, we want to solve them equal to 0. So we have 2r minus 1 times 5r minus 9 equals 0. So either 2r minus 1 equals 0 or 5r minus 9 equals 0. Either 2r equals 1, so r equals half, or 5r equals 9, so r equals 9 over 5. Of course, we have two solutions here for triple I, since this is an algebra question. But for the probability context, we cannot use both values. We can only use r equals half, because r cannot be greater than 1, since it's a probability, so it must be less than 1. So 9 over 5 would not work. Therefore, r equals half. And the probability that Benoit does not cycle to school is 1.3 minus half, which is 0.8 as a final answer. So 0.8 is correct. And 9 over 5 and half are correct for triple I. And the rest is fine as well. Now we move on to expectations. The probability that Kim wins a game is 0.72. In 1 year, Kim will play 225 games. Work out an estimate of the number of games Kim will win. Of course, you just need to understand that an expectation is the probability times the number of events occurring. So the answer is simply 0.72 times 225. You can use your calculator to evaluate. So 0.72 times 225 gives us 162 games in total. This is the final answer here. A bag contains blue, red, yellow, and green balls only. A ball is taken from the bag at random. The table shows some information about the probabilities. Complete the table. So since it only contains blue, red, yellow, and green, we must understand that the sum of these 4 entries must be 1. So we can write an equation like this: 0.15 plus 0.2 plus x plus 0.43. All of this combined gives us 1. And we can use the calculator to simplify the left-hand side. So 0.15 plus 0.2 plus 0.43 gives us 0.78. So 0.78 plus x equals 1. We subtract 0.78 from 1. And this gives us a value for x, which is 0.22. And then for question B, we are told that he repeats the experiment 200 times, and we want the number of times he gets a red ball. So the probability of red is 0.2, and therefore the answer is 40. So we have 0.22 for A and 40 for B. Sophia has a bag containing 8 blue beads and 7 red beads only. She takes out 1 bead at random and replaces it. She does this 90 times. Find the number of times she expects to take a red bead. So again, this is the number of times she does the experiment times the probability of red. So the probability of red here is 7 over 8 plus 7, which is 7 over 15. And the number of times is 90, so the expectation is 90 times 7 over 15. And this gives us 42 as a final answer. And this is the correct answer here. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.